Hello everyone, this is the second part of chapter 9 revision. In this question it says determine whether each pair of polygons is similar. If so, write a similarity statement. We say that two shapes are similar if the ratio between the corresponding sides is equal or constant. Like here, the corresponding sides, we can take the shortest with the shortest and the longest with the longest. Let's say here the shortest is 100 and here the shortest is 150. The ratio is 100 over 150. Okay, this is the first corresponding sides. The other corresponding sides, if we can take the longest with the longest, it will be 101 divided by 151. If the ratios are constant, then we say they are similar, otherwise not similar. And if you divide them, you're gonna find that they are not equal. When we divide 100 by 150, it's not equal to 101 divided by 151, not equal. So they are not similar, not similar. Okay, let's go for the second question. Again, we're gonna find the ratio. If the ratio is constant, we're gonna say that the shapes are similar, otherwise not similar. Let's start with the first pair of corresponding sides. We're gonna take the shortest AB with the shortest FE in the other shape. The ratio will be 15 divided by 5, which is 3. This is the first ratio. Now let's go for the second. The second longest is 22.8 and here we have a 7.6. This is the corresponding sides. Let's divide them. 22.8 divided by 7.6. Is this equal to 3? What I'm going to do, I will multiply 7.6 by 3 to see if it's equal to 22.8. 3 times 6 is 18, 3 times 7 is 21, plus 2 plus 1 is 22.8. So yes, it's equal. We have the same ratio. We have to continue to check if all have the same ratio. Now let's go for the next sides. I'm going to choose 24 with its corresponding, which is 8. 24 divided by 8 equals to 3. So far we have the same ratio, and the last side length is the longest, which is 45. I will divide it by the longest side in the other shape, which is 15. 45 divided by 15 is 3. So yes, we have the same ratio. We can say that these two shapes are similar. For this question, it says determine whether each pair of polygons is similar. If so, write a similarity statement. Here we forgot to write the similarity statement. Okay, we're gonna start. Polygon A, B, C, D is similar to polygon. Remember, the order is important. Since we started with A, which has one arrow, we have to look for one arrow in the other polygon, which is E. So A and E are corresponding. Then B, it has two arrows. We have to look for two arrows. We have F, and then we have C. The corresponding for C is G, and the last one is H. This is the similarity statement. Now for this question, are they similar? Okay, we have the rule AA similarity, which says that if we have two pairs of congruent angles, they have the same measurement, we say that the two triangles are similar. If we have AA similarity, two pairs of congruent angles. The first pair, we have it here, 50, 50. This is the first pair. We have a pair of congruent angles. And the other pair, is W. W here is common for both triangles. Vertical angles have the same measurement. So yes, we have two congruent angles. We say A, similar. Since we have two congruent angles, and the similarity statement, if we started with X, W, Y, we can say triangle X, W, Y is similar. Since we started with X, we have to look for the corresponding angle of X, which is V, triangle V. Then we say W, W is common, U. So triangle X, W, Y is similar to triangle V, W, U. Okay, now let's go for question number 4. We have to look if we have two congruent angles, two pairs of congruent angles. We have one pair here, 48, 48. The other one, it's not the same, but we have to check R. To do that, we know that the sum of the interior angles for any triangle is 180 degree. If we add them, 48 plus 65 plus the missing angle here, which is R, equals to 180 degree. So let's find it. 48 plus 65, and we're gonna subtract it from 180. 5 plus 8 is 13. 7 plus 4 is 11. 113. We're gonna subtract that from 180. 180 minus 113. This will be 7, this will be 10, 7, 6, 0. So the measurement for angle R is 67 degree. Now let's find the measurement for angle U. Measurement for angle V plus the measurement for angle T plus the measurement for angle U equals to 180 degree. Measurement for angle V is 48 plus the measurement for angle T is 57 plus U equals to 180. Let's add first 48 plus 57. 7 plus 8 is 15. 5 plus 5 is 10. 105 plus U equals to 180. So the measurement for angle U is 75 degree. So as you can see here, we have only one pair of congruent angles. So we say no, they are not similar. Not similar. Okay, now let's go for question number 5. In question number 5, it says that we have a similar polygons. Since they are similar, the ratio between the sides length is constant. And we have to find the missing side length. Here we have this side length is missing. To find it, we're going to do x divided by the corresponding side. The corresponding for x is 5.6. So we're going to say always I want you to start with a variable. X divided by 5.6. Since they are similar, the ratio will be constant. Now take another pair of corresponding sides. I will take NO. This side length is corresponding with TU. So we started with X, start with 10. 10 divided by 4. Okay, now we have to solve for X. I will move the division and move it to the other side. It will be multiplication by 5.6. The value for X is 10 times 5.6 divided by 4. First I'm going to multiply 5.6 times 10 is 56 divided by 4. 56 is 16 plus 40. So we can divide it to 10 times plus 4. 10 plus 4 is 14. And we can make a long division if you want. 5 divided by 4 is 1. And the remainder is 1. 16 divided by 4 is 4. So the value for X is 14. Now let's go for question number 6. In this question also we're going to do the same. Start with the variable X and divide it by its corresponding side. This side length is from L to M. and the corresponding will be from C to D. This one is the corresponding side length. 18 is equal, I'm gonna take the shortest with the shortest. JK is the shortest, 3, and its corresponding is 6. So since we started with X, we're gonna start with 3. 3 divided by 6. Move the division for the other side. It will be multiplication. X equal to 3 times 18 divided by 6. I will simplify. Divide by 3 is 1. Divide by 3 is 2. Divide by 2 is 1. Divide by 2 is 9. So the value for X is 9. And as you can see, the ratio here is 2. The scale factor is 2. We multiplied here by 2. So also this value, if we multiply it by 2, we're going to have 18. 9 times 2 give us 18. Okay. Which of the following is true about triangle ABC and triangle XYZ? Select all and that apply. First, let's check if they are similar or not. As you can see here, we have a 3. And the shortest on the other side is 6. These two are corresponding. The scale factor is 2. If we divide 6 by 3, give us 2. The scale factor is 2. Now if you take another pair of corresponding sides, 7 and 3.5, and we divide them, 7.5 7 divided by 3.5, this is also equals to 2. So the ratio between the corresponding side is constant. We say yes, they are similar, the triangles are similar. And this symbol is the similarity symbol. Okay. Okay, now let's go for the first question. Here we have a similar triangles because we have a similarity. Here we have a right angle, and here also we have a right angle. This is the first pair of congruent angles. Here also we can see that they are congruent to each other. So we have a similarity triangles, they are similar. Since they are similar, the ratio between the corresponding sides is equal. So to find the missing dimension, to find the value for h, we're going to take the ratio between the corresponding sides. H is corresponding to 3. So h divided by 3 is equal, we need another pair of congruent sides, 7 with 4. This is the second pair. Since we started with h, we're going to start with 7. 7 divided by 4. Now let's solve this equation. We have a division. We're going to move it to the other side. It will be a multiplication. H equal to 7 times 3 divided by 4. 7 times 3 is 21. 21 divided by 4. 20. If we take the 20 divided by 4, this is 5. And we have 1 remainder. 1 out of 4. This is 1/4. 5.25. And the unit is feet. Now let's go for the second question. Also here we have a similar triangles because a similarity. This is the first pair of similar angles, and we have one in common. So the first small triangle, this is the first one, and we have the big triangle. Okay, these two triangles are similar, so the ratio between the corresponding sides is equal. The height is missing, the height of the flag is missing, and the corresponding side for h is the height of the child, which is 6.5. So we can say that the ratio h divided by 6.5 is equal to another pair of corresponding sides. I'm going to take the base of the large triangle, which is 31.5. And I'm going to divide it by the base of the smaller triangle, which is 9. So 31.5 divided by 9. Again, we're going to take the division to the other side. It will be a multiplication. The height of the flag, it will be 31.5 times 1 out of 9. I just remove the division. It will be 1 out of 9 times 6.5. Now I'm going to convert the mixed numbers into to improper fractions. Multiply and then add. 2 times 31 is 62 plus 1 is 63 out of 2 times 1 out of 9. Also here do the same. Multiply, then add. 2 times 6 is 12. 12 plus 1 is 13 out of 2. Simplify. We have a common factor between the 9 and 63. Divided by 9 give us 1. Divided by 9 give us 7. 7 times 13 divided by 4. 2 times 2 is 4. So 7 times 13 divided by 4. 7 times 10 is 70. And 7 times 3 is 21. 70 plus 21 is 91 divided by 4. Now start dividing 9 by 4. 9 divided by 4 is 2. And the remainder is 1. 11. 11 divided by 4 is 2. And the remainder is 3, because 2 times 4 is 8. We have 3 as a remainder. Remainder 3 divided by 4, so it's 3 quarters. 3 quarters, it's 75. 0, 22.75, and the unit is feet. Okay, now let's go for question number 3. Also in question number 3, we have a similar triangles by AA similarity. Also it's given for you in the question that they are similar. And we have to find the height h, the missing side length. To do that, as we said, since they are similar, the ratio between the corresponding sides is constant. H and the corresponding for h is 2.5. So h divided by 2.5 is equal, as you can see here, we have, let's start with the smaller triangle, with this one. The base of this triangle is 20 minus 2, because 20, it's the whole distance from A to D. I want the distance from A to E, so I'm going to take out the 2. So this side length is 18 divided by the base for the big triangle, which is 20. This is the whole base, the distance from A to D, which is 20. Okay, now I will move the division by 2.5 to the other side. It will be multiplication. H is equal to 18 times 2.5 divided by 20. So what I'm going to do, I will simplify by dividing by 2. This is 10. Divide by 2. This is 9. Now let's multiply. 9 times 5 is 45. 5 down and 4 up. 9 times 2 is 18. 18 plus 4 is 22. And we have 1 digit in the decimal part, so also my answer should contain 1 digit in the decimal part. Divided by 10. If we have a division by a power of 10, you have only to move the decimal point by the number of zeros. We have 1 0, so we're going to move it, since we have a division, we're going to move it to the left. 1 step to the left, it will be here. So the final answer is 2.25. Okay, now let's go for the second question. Question number 4. Here we also have a similar triangles, and we have a missing dimension, which is D. Now since they are similar and the ratio is constant, start with a variable D and take the corresponding side for D, which is 10. So D divided by 10 is equal to take another pair of corresponding angles. I will take this one, which is 45. And as you can see, this line connects between the angle, here the common angle, and angle with 2 curves. The corresponding side is this one. Actually, it seems that we have isosceles triangles. Anyway, 45 divided by 21 move the division to the other side, it will be multiplication. So the value for D is 45 times 10 divided by 21. I will simplify. We have a common factor. Both 21 and 45 are multiple of 3. Divide this by 3, give us 7. Divide this by 3. 4 divided by 3 is 1, and the remainder is 1. 15 divided by 3 is 5. So 15 times 10 divided by 7. 15 times 10, this is 150, divided by 7. Start dividing the 15. 15 divided by 7 is 2, and the remainder is 1. So now we have a 10. 10 divided by 7 is 1, and the remainder is 3. So 3 out of 7. This is the final answer. Okay, now let's go for the last question. It says we have a house with 25 foot tall, casts a 75 shadow. Let's do that. Let's graph it. Let's see. This is the height of the building, which is 25, and it casts a 75 foot shadow. And if we connect this point with this point, we're going to have a right triangle. This is for the house. And it says that we have a street light that casts a 60 foot shadow. We have a street light that casts a 60 foot shadow. And if we connect these points again, we're going to have a right triangle. The question asks me to find the tall of the street light, the height of the street light. So what we're going to do, we can solve it using the same method as before. But what I will do, I will say that the height of the building was 25, and this makes a 75 shadow. So we multiplied the height of the building by 3 to give us the shadow, which is 75. So here also the height of the street light, if we multiply it by 3, will give us 60. So what is the number? If we multiply it by 3, give us 60. The answer is 20. The height of the street light is 20 feet.